Hi everyone, welcome to the video on file input and output. There is a lot that we are going to cover together, so we're going to go through all the demos and the exercises in the video, just because file input and output is a little bit complicated, and I want you to make sure you have a very good grasp of it when you go on to do the lab exercises and the assignments. So I'll try to talk through everything that's in those demos and those exercise solutions as we go. But if you have questions about it, as always, just stop by Help Hours and we'll answer anything lingering that we may not have addressed in the video here. So in this first demo, we're asked, what does the following processing code do? And when we look at this, there's a couple of things that look familiar. So line 1 here, we have a variable that we're making and we're assigning a value of 1 to it. We have a comment beside that that tells us that that's going to be the current line of the file being read. If we skip through a little bit of this here, we have some fills and some ellipses. We're used to that kind of thing. But there is quite a few different commands in there that we haven't seen before. So the first one that we'll see for the first time is on line 2 here, where we have a variable that we're calling f. And we are assigning it a value of whatever's returned by this open function. And this is the first time we've seen the open function in this class. Effectively, you can think of the open function like you are double clicking on a file with the mouse. It's just telling the computer in a programmatical way, hey, we want to open some file that we're going to specify to do something with it. And what's really funny about the open function here is the first argument it takes is a string with the file name. And the second argument is like the biggest heads up you could possibly think of. This really gets back to the whole analogy of like the computer acting kind of like a toddler. It's kind of like us prepping our toddler, being like, hey, we're going to go to the grocery store later. You're going to have to do these things, la 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 la. This is like, hey, Mr. Computer, just so you know, in a little bit, we're going to read something from this file. You don't have to do anything yet, but just so you know, we are going to be doing that. And so whenever I'm writing those open commands, that's what I'm kind of thinking in my head. So that second argument can either be R for read or W for write. I'll give you a bit of a spoiler. In CMPT 141 and 145, you'll find out there's also a third option called A for append, but we won't use that in this course. And the first argument here is a string that is the file name. Now that file needs to be in the exact same folder that your processing code is. And I'll show you a little bit of a hack of where you can find that folder really quickly when you're in processing, so you can double check that it's in there. And in this case, we're reading something called csmajors.txt. So if I open that file up, what it looks like, oopsie, is just this here. So we have 4 different lines with what looks like a year, then a comma, and then some sort of number. Now I know a little bit of context around this. What this actually is the number of CS or computer science majors in each of these academic years. So that's what we'll be reading in. Typically when we open a file to read, the very next line we're going to have, or one of the ones like shortly following, is going to be a for loop. Because we're going to say, okay, we've opened our file. Now we want to do something with every single line in that file. And the easiest way we can do that is a for loop, because the wonderful Python developers have built in that functionality that if we just use the for loop, it already knows how to parse through line by line for us. And then we can just do things line by line. And so we've seen the for keyword before. This case, we're just specifying a variable called line that's going to represent a line of data in our file. And then we're using that in keyword, which we've seen before. And then the variable of whatever we called it for where we were opening that file. So that's going to store what we would call a file object. And that's just like our open file we have. So think of double clicking it, a new window pops up. It's like associating that variable with that window. You can kind of think of it like that. And so for every line in our file, we're going to do all of this different, whatever's in our body of our for loop here, all of these instructions. And some of these instructions are more familiar, so like our fill and our ellipse. And some of them we haven't seen before, so things like our strip and split. And we'll go through line by line what each of those are. So the very first thing we're doing here is we're saying, okay, strip out whatever this is. And in this case, this is a new line character. So remember from the textbook, we said that's the value that actually gets put into the computer when you press the enter key on your keyboard. It's abstracted from a human who's looking at a file, but it is there in the back end because it tells the computer, okay, start a new line. And it needs to have that information to know, otherwise how would it know? But it's hidden from us. And we don't want to incorporate that into what we're doing with the rest of the data in that line. So oftentimes we'll want to remove it. So we'll just have like the very first thing in our for loop is going to be removing that new line character from the end of that string. And so as a reminder, when we're reading from files, the line of information that we get in each time is going to be represented as a string. So this rstrip method is actually a string method. We could use it for any string that we come into contact with. And you could also specify different characters here if you wanted instead of that new line character. So say you wanted to remove trailing A's from a string, you would just put A at the back there in double quotes instead of /n, and that would do that. You can try that out on your own if you're interested. Once we've removed that new line, we're then taking the data, which we've stored in this variable called CS majors, and we're splitting it by that comma variable. So remember we said it was a comma separated value. We had that year and then we had the number split by a comma. And what this is going to do is it's going to return to us a list that's going to have that year and then the number. I'm just going to write it like this because I'm not going to try to draw with my horrible drawing skills all that information in that file. So every single line will have a list which we can then index to get those values out of. And that's exactly what we're doing on this next line here is we're indexing the second element in that list to get the number of majors. So remember, if I just bring this over again, whoops. Oh goodness, come on now. Oh, it's just trying to automatically fill into my other screen. Being too helpful, Mr. Computer. So it's going to grab this second value that would be the second element in our list. It's then going to draw a circle where the size is related to that value. And then we're going to fill in some text that's going to be based on the first element in the list from that line. Increase our line number by 1, and then continue until we've read through all of the lines in that file. And then finally at the end, we're closing that file. So just like we mentioned in the textbook, because we're reading from a file, if we forget to close it, it's not the end of the world. If we were writing from the file, it'd be more problematic. But it's effectively, you can think of it like saying, okay, I'm all done with this. We're going to save and we're going to exit out. If we leave all these files open, that'd be like my second screen that I have over here that I'm not going to show you. As all these different windows open, it's absolutely chaos, right? We don't want the computer to experience chaos. And when we're writing files, it's like saving that file for us when we say the close command or the close method, sorry. So we always want to get in the habit of closing a file when we're done with it. And you'll note that it's not in the same indent or the for loop body. It's at the same indent as the other ones that are outside of the for loop because we don't want to close it every iteration of the for loop because the computer would freak out at us and be like, what? You close this file, now you're trying to do more with this file? I can't handle that. And I mean rightfully so. So now I will just bring over, I pre-typed over all of this code so you didn't have to watch me, but it's the same thing from the slide. And so let's see, do we get our circles that are different sizes based on those numbers? And then do we get those years that are read in as well? So if we run this, that's exactly what we get. You can see that as the years go on, the number of computer science majors increases as denoted by the size of those circles. So pretty cool. And it's really nice to have that ability to read in from files so that we can take other data that's available and just do something interesting with it instead of having to hard code that all into our programs like we have been doing up to this point. So for the first exercise here, we're going to read in from a file called sprite.txt. And what that is it's going to represent a pre-rendered drawing. Those are often called sprites. And in this case, we just have fill commands and ellipse commands, and they're all on different lines. So our fill commands would be followed by the 3 arguments that are needed for fill after that. And then the ellipse commands are followed by the 4 arguments that would be needed for ellipse. So we're going to go through, we're going to read that information in. This is what it looks like if in the full file. So you'll see we have a whole bunch of different lines. If I look at this just now, I'm like, I have no idea what that's drawing. My brain has not had enough coffee for that today. No, thank you. Let's get the computer to tell us instead. So one thing that we need to do is we need to make sure that that input file is in the same area that our processing code is, or the same folder. So one way we can check that very quickly is by going to this sketch tab up at the top by file, and then going to show sketch folder. There's, you see beside it too, there is a keyboard shortcut, which is Control K. So you could try that as well. And when you do that, what happens is it brings up a file or like a finder window where it has that program as well as any other files that are in there. So that sketch.properties is really common, and then any input files that you have. If you're getting errors when you're trying to read and write things, double, triple, quadruple check that your input file is actually in the spot that you want it to be in. 99% of our errors when we're dealing with file input and output are because that file is in a different folder than we thought. So always check through that sketch that it's actually where you want it to be, okay? All right, so I'm gonna make this just a bit bigger so that we can see all of the wonderful, beautiful code that we'll be creating together. We'll just make it the whole size of the window. Why not? I usually leave the background so I can move that if I need to, but this is all good. So I'll just add in some single line comments that are going to show us kind of the overview of what we're going to do. So first we're going to open the file, and then we're going to go through each line of the file, and we will draw the image in the line, okay? So let's start at the top here, and let's just start by opening that file. So again, I'm gonna just use F as my variable name. It's kind of like a convention in computer science for that to be like input file or F. F is a safe bet in Python. It's not a keyword, so we can use that to represent our file. So saves us a little bit of typing, so you'll often see us use that for our variable that's storing or holding that file. We then use our open function, and we pass in the file name, which in this case is sprite.txt, and we tell the computer, hey, just a heads up, we're going to be reading from that file. Sorry, I feel a tickle starting in my throat. Then we're going to say, okay, let's go through line by line. Just a second. Now you can tell that I don't edit my videos. So for the for loop, we just use our for keyword. Then we do a variable. This could be L, this could be K, this could be rider. We're going to call it line so it makes more sense to someone who is reading through our program. So for each line in F, we are going to go, oh, and I didn't put this through with my comment. Oh, major professor faux pas. Let's first clean our data. So clean the data. So that's going to be using those rstrip and split commands. So remember, with our sprite, we have it. Oh, that's the CS major one. Here's my sprite folder or file. It's also comma separated, so we'll be splitting based on that comma again. So first, we're going to just make a variable called data that's going to hold our clean data for us. Then we're going to take that line that we're reading in, and we're going to remove using rstrip that new line character. Now I need to make sure I do the slash the right way. I often do the slash the wrong way. You know, just a genius over here some days. And then I get an error and I'm like, oh, I have to fix it, yada, yada, yada. I'm pretty sure that's correct though, but we'll see. Then I'm going to comma separate all that data that has the new line removed and store that just back in data, but it will store it as a list. So then we say data equals data dot split, and we're splitting by the comma. Now what I'm going to do here is just print data to see, okay, do I actually have that new list of our clean data without that new line? So I would expect a list with each element being a string that represents the data that we would see in that folder. And it should pop up here on the console, which it does. So we can go through and double check, oh, there's all of the different lines. We have fills, we have zeros, and we have numbers, and yada, 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 all the way through. So good, I can remove that print. I know that that's working as I would expect. Now I want to draw my image. So we either have fill or ellipse as that very first element in our list for the line. And we're going to want to do a fill command if it is a fill, and an ellipse command if it's an ellipse. So because I'm already saying if it's this or if it's that, that should be kind of triggering in your brain some, oh, hey, maybe we want an if statement. And in fact, we do. So we want to check to see if data 0 is equal to fill. If it is, we'll do the fill command. And then we're going to pull out the very next 3 elements in our list, which represent the numbers we're passing into fill. Now you'll notice that when we printed them out, they were strings. So remember, as we're going through line by line of the file, that's actually pulling out strings. So we're going to need to tell the computer, hey, computer, guess what? I'm still smarter than you. I know that should be an integer. So we're going to use the int command, convert that string to an integer. So all we would do is say int, and then we pass it in data 1. Oh, and I'm not going to forget my bracket because I just bragged about being smarter than the computer. Data 2, bracket, int, data 3, bracket. And that would be for our fill command. If it's not a fill, let's check to see if data 0 is equal to an ellipse. If it is, we'll call the ellipse command, and again, we'll be passing in those different integers. And ellipse, remember, has 4 different arguments, so we will have 4 calls after here. So 1, 2, 3, and 4. When I was first typing this out before while I was preparing, and I was just making sure that everything was working as I expected on my machine for input and output, I forgot my 4th argument, and it was giving me a silent error and just not drawing anything, and I was like, oh boy. And I couldn't figure out why. It took me a solid 15 minutes to be like, right, that's what I'm missing. It happens to the best of us. So we have all that, and at the end here, we want to make sure we close our file. So f.close. Remember, that's outside of our for loop. So it would be same indentation level as when we call the for loop and as when we open the file. I'm also just at the very top here going to adjust my size of my canvas so that I can see all the different things here. Because look, I have some pretty big numbers down here. If I just left it default, it's probably going to draw it somewhere where I can't see it. So if I run this now, let me find this. Look at my little turtle. How cute. One of the girls I work with has a pet tortoise named Herman, so we will call this Herman the tortoise. Very, very neat. All right. So that's all the examples we're doing with reading files. We're now going to get into writing files. So writing files, very similar idea. We will open a file to read. We'll specify the name we want that, a file to write. We'll specify the name that we want to give that file. We'll then go through and line by line specify what we want printed or written to that file. Then we'll close it. We should be able to see it. So in this case, we have a list called dots that's going to represent integer locations of points in a connect the dots drawing. So connect the dots drawings are just pages that have dots all over them, and you have to draw lines in between them, and then they make some sort of image. So every 2 data items in the list is going to represent an XY coordinate for one of the points. We're going to write processing code that writes the dot coordinates with 1 XY pairing per line to something called puzzle1.txt. So over here, let me just bring over where I have the folder made. I have a folder that I've called just CMPT 140, chapter 15, write dots. I have a processing file in there that I've started. And you'll see there's no puzzle1.txt so far. If I open up this processing file, the only thing, I have my other code that I tried. I'll delete it first. I won't cheat, I promise. The only thing I have in here is my list of the different locations of XY pairs that I want to write to my file. So I have things like 10-10, 50-50, all of these different things, okay? Well, I guess this is a demo, so I could have left that. That's fine. We'll just write it up again. So those are all of our values that we want written. If we want to write to a file, all we do is say f equals, and again, could be a different name other than f. It's whatever variable name you'd like to use. The very first argument to open is going to be the file name we want to give it. So puzzle1.txt. And then instead of an R here, because we're not reading the file, we're telling the computer, hey, heads up, we're going to be writing to this file. So get prepared. Do whatever you need to do. Mentally prepare yourself to start writing some data for us. Inside of that, we're going to do a for loop. And our for loop, we want it to be the length of this list, right? So we know we're going to want it to be the length of that list. But we also know that we have to print both of these each in one line. Because I know I'm printing pairs, I'm going to do a custom range that goes from 0 to 1 almost, or 1 minus the length of the list, and goes up by 2 every time. So that I know I can take 2 elements every time and not be repeating anything. So for D, for dot, could be whatever you want to call it, in range. And I'm going to do 3 values for my range. So I'm going to start at 0. I'm going to go to the length of dots, which is our list that we have there. And I'm going to use a step of 2. So remember, we can specify the step size with range. And that's just going to go up by 2 every time. So it'll start at 0, then it will go to 2, or then 0, then it will go to 2. Yes. Me making sure I'm doing my math right. And then 4, and so on until it reaches the end of the list. So each time I'm going through my loop, I'm going to pull out my x coordinate, and then I'm going to pull out my y coordinate, and then I'm going to write those 2 things to my file. So I'm going to say x coord is equal to dots d. My y coord would be equal to dots d plus 1, because that would be effectively like me taking 0 and then taking 1. And I have both of those. You'll notice that up here these are integers. And if you're remembering from the textbook, you're probably already screaming at me through your computer screen saying, Professor Kim, we need to make those strings if we want to write to the file, else the computer's going to yell at us. And you'd be 100% correct. So we know that we need to convert these into strings. So we could do it here. And again, it'd be just like how before we were taking the strings when we were reading from a file and converting it to integers. We just use the str command that we talked about like so many chapters ago, it feels like. And that's going to say, okay, I know this is an integer, but I actually want it to be a string because guess what, computer? We're smarter than you. And then to write to the file, all we do is f.write, and then we pass in the values we want. So in this case, we want x coord, and then we're going to concatenate that with a comma. Remember, we can do string concatenation using the plus, and then y coord. You could also build this up outside of the write, save it in a variable, and then just write the variable if you wanted. It's totally up to you. Now, if I do this, and I'm going to do this just for sake of argument, at the very end I'm going to close, there's an error in here, and I want to know if anyone can find it. While I run this, and before I open it, if you can find the error, you get a bonus point, but the bonus point doesn't matter. It's just like the Whose Line Is It Anyway show that I used to see. You'll see that nothing is displayed to canvas, nothing is displayed to console, but if I open that. Oh gosh, and it didn't work. It's already yelling at me about something. If I open the folder that it's in, we should have a new folder or file created called puzzle1.txt. So here I'm going to go show sketch folder. We bring it over because it opened on my other screen, and we have puzzle1.txt. Anybody see my error? That's not what we want. I think we want some of these in it. What am I doing? I'm pressing my enter key. You probably have all figured it out by now. We need some new line characters. We need to tell the computer, hey, press the enter key. And I am most likely put in the wrong backslash, but I'm not 100% positive. So I didn't save that text file. I'm going to rerun this. I think it reran. I think I have all of these gray canvases open. I'll show my sketch folder. Beautiful. Look at that. I didn't put the slash in the wrong way. I'm very proud of myself. We have lovely spaced out X and Y coordinates on new lines because we added in our new line. Okay. So that's a little example of how we can do that. So for exercise 2 here, we're going to do something very similar. We're going to take a list called markers that's going to contain information for drawing a set of circular map markers. Every 4 items in the list are going to represent a single marker's color, its X coordinate, Y coordinate, and radius. We're going to write some processing code that writes all the marker descriptions to something called markers.txt, such that each marker's description is on its own line. And so here's where we get a bit of an example here. So we have a list, we have our red marker, its X, its Y coordinate, and its size or its radius, and then our green, and so on and so on. So this is like every 4 elements in our list is all related, and we want that to be on a single line. So our last example was every 2 collections or every 2 elements in our list were related and need to be on our own line. Now we need to do it so every 4 are. So again, I'm just going to go over here. I have it all in my downloads here because I started saving them in my downloads and I just committed to it. Even though I should probably have all of my exercises and like my documents neatly organized. Some days I just choose chaos and save everything in my downloads. You download one thing and then it's like, you open it up in processing and it's like, oh, you must have your processing exercises there. And then it just automatically wants to save everything there, and I did not feel like changing it. So you'll see I don't have my markers.txt file here yet, but I can open up my processing. Where is it? That was our dots. Here we go. We have our markers starter file here with my list of all of the different markers and things that I want to write out to a file. So the very first thing I'm going to do here is, again, I'm going to open a file. I'm going to say, hey computer, guess what I'm doing again? I want to make a new file called markers.txt and I'm going to write to it. So get prepared. I'm then going to go through my whole list here, and again I'll be making a custom range that goes up by 4 since we said every 4 elements are related here and we want to keep them together. So we'll say 4 M in, and I'm just picking M because it stands for marker range, but you could pick whatever you wanted. 0 len markers, and then instead of 2 for our step it'll be 4, and we will do, again, collecting all of the information that we want to write out. So we could say output, for sake of argument, is going to be equal to our markers M. And then I'm just going to build up my big string that I'm going to output here. So here's my comma. I won't even add. I won't even add my beautiful, my beautiful space in between this time. I'll try to be better. And I'm going to put these all on different lines for now, just to make things a little bit easier for me. We could add them all into one line after, but it'll be easier to see all of my information instead of going all the way off the screen just because my font size is so big. So we want our green for sake of argument, and then we want the x-coordinate, the y-coordinate, and the size all into one line. And so because these other x, y, and size are all integers, we need to convert them into strings. And I have caps locks on all of a sudden. Markers m+1 plus, like comma, plus another one, markers m+2. And instead of doing this hard coding all of this, we could actually use a nested loop. And the solution that we have posted in PDF shows you how to do it with a nested loop instead, so that you save a little bit of typing. m+3. That should be all of them. And then we will add in our new line so we don't forget it. And then f.write output. And outside of my for loop, I will close it. Now let's see if this will run. I can't remember if Python is okay with us doing these big strings like that. No, it's so upset. So I'll just put it all on one line here. It will go off the screen, but that's okay. I think Java is okay with it once you get into Java in second year. And again, as I said, I've been doing a little bit too much with Java lately for some reason. So all on one big line. Did I forget? I did. I see. It might have actually been fine, and I just forgot a bracket. And now I've forgotten another bracket. Maybe there's unclosed something. Yep. So many brackets I've forgotten. Oh my goodness. I clearly need some more coffee after this. That'll be first thing on the list to do. Gosh. Bracket, bracket, bracket. Now we try again. Okay, no errors. Things are happy. The gray box popped up. If I open up my sketch folder, I'm not seeing anything here. Let me save this and try running it again. Let me open up my sketch folder. There it is. I've noticed on mine for some reason sometimes I have to run it twice to get the file to show up. And it's maybe sometimes because I don't save. So if you're having that same problem, try running it twice. And then your file should show up. Or my computer's just incredibly slow, one or the other. So there we go. All of the information we wanted, output like that. Highly recommend checking out the solution so you can see how we would do that with a nested for loop instead. All right. I will be back shortly with the very, very last chapter of CMPT 140. Oh my goodness.